Today we're going to build a simple AI agent in Python using LangGraph. We will explain the basics of an AI agent. We're going to build a simple console application where we can interact with our agent. We're going to add personality, tools, and memory to our agent. I am Kostas. This is Computer Geek channel, Pame. Before we jump into the code, let's very quickly define what is an AI agent. When I say an agent, I mean more than just chatbot. Functional-wise, you can think of an agent as having four key components. First of all, it can have a language model. This is the brain that understands and generates text. Then it may have some memory, some state, so it remembers the conversations in previous steps. It might have one or more tools, essential functions it can call to do things like getting the current time, looking at the weather, searching, whatever. And last but not least, a controller. That's something that decides, hey, do I just answer, do I call a tool, or do I continue the conversation, etc. So how does this look like in LangGraph? To follow along, you will need basic Python knowledge for like running scripts, installing packages, an LLM API key. I'm using OpenAI, but you can also use Anthropic, and a terminal where you can run Python scripts. Everything else, LangGraph, agent setup, we will do that in the video. Okay, so let's begin. Here we have a very empty project with a very simple application. So first of all, we're going to need a virtual environment. So this project packages don't mess up with the global Python. Okay, next we're going to create the requirements.txt. So this is where we list the libraries we need for the agent, and we'll go ahead and install them. Last but not least, we're going to create a .env file. So this is where we're going to put our LLM API key, and we can also specify which LLM provider we want to use, OpenAI or Anthropic. Now that everything is in place, we can start running our application. And as you can see, at the moment it's not doing anything, it just prints a hello world message. All right, now that we have our prerequisites down, let's improve our application a bit. So at this point, we're not doing anything smart yet. So functional-wise, the application is not doing anything smart. It's all about getting the user input. So the application can start. It prompts the user for some input and preparing a place where we will later plug in the real agent. Okay, next, let's change our fake agent with an actual agent from LangGraph. So first of all, we're going to create a helper method called getModel. We're going to use it to dynamically either create an OpenAI model or an Anthropic model. Okay, now that we have a model, let's also create an agent. To create an agent, we can use the create agent. So for the agent, we're going to be using the helper method create agent. And the only required parameter here is the model, which can be a chat OpenAI model, Anthropic model, or like they also support other models as well. And now let's try to make use of this agent. We're going to delete this hard-coded response, and we're going to use agent.invoke. Now, when using agents, there is a specific format, how the message history is expected. And whenever a user sends a message, that always needs to be a human message. And that's what we're doing here. So we're getting the user input, we are converting that into a human message, and we are invoking the agent asynchronously. Let's see how this looks like. I'm going to start the application once again. Hi. Nice to meet you. As you can see, our agent is already fully interactive. Okay, next, let's try to give our agent a soul. So right now, whenever we ask something from our agent, it always replies in a very bland format. What wants to make it a bit more fun? So we're going to add a system prompt. So system prompt is basically an instruction that agent's going to take into account every single time before replying to you. And we have to give this to our agent. And now let's rerun our application again. Let's exit and we run it again. Hi. So as you can see, now it's gonna reply in that ancient Greek sitting philosopher style. Let's ask something else. To be or not to be. And as you can see, it's gonna continue in that philosophical style from the ancient Greece, right? Okay, our agent can definitely talk, but it cannot do anything yet. Let's give him his first tool. So we're going to create a new tool called getWeather. We're going to give it as a parameter to the tools, to the create agent. And we also are going to import some dependencies here. So what is a tool? Tool is essentially a function. It can come with its own schema. It can have some defaults. It can have descriptions for those fields here. And all of this information is going to be available to the agent. And so the agent, for instance, is going to be able to know that the units has a default value Celsius. And also that from the description, it will know that, okay, this is going to be the temperature in unit preference, right? And to create a tool, you can use these annotations also provided from LangChain. And now let's see how this is going to affect our agent. So I'm going to exit the previous instance and I'm going to run it anew. Let's try it out. What is the weather in Athens? Okay, as you can see, our agent did indeed call this tool getWeather. It also specified the name of the city, Athens, properly, and the rest were used by default, right? Unit was Celsius and include forecast was set to false. Let's now ask it, now give me the weather in Cologne in Fahrenheit. As you can see, the agent was smart enough to adjust the inputs based on our prompt. Okay, now we also showed how we can have a tool with its own schema where you can basically have type safety. One of the key limitations right now is that our agent has no memory. And to test it, I can tell it my name is Costas. Good. What is my name? And obviously it cannot tell. It actually doesn't have any memory right now. So let's improve that. Okay, to give our agent memory, we need to use a checkpointer. So this comes also from LangGraph. Memory saver. And the default memory saver is in memory. It essentially means that when you are running the application, everything is stored in the memory of that application. As soon as the application is closed, the memory is gone. But you can also use persistent memory savers. For instance, you could use Redis or some other or even database to store your sessions and the message history. Okay, to use that, we create a checkpointer. Let's also give that to our agent. So now our agent has memory. But another important part is this configuration object. So you can see in this configuration object, we have the thread ID. When the message is being stored, or when the agent is replying, it's always replying and saving the message history in a specific thread. Later on, if you want to allow the agent to communicate with multiple users, here you could use the session ID. In our case, we only have one instance, and what we need to do is when invoking agent, we also need to give this thread configuration here as a parameter. So once again, if you want to allow the agent to respond, to talk to multiple users and keep their history separate, here you could basically have a session ID. So let's try it once again. Exit, let's run our application once again. Hi, my name is Costas. Good, what is my name? Oh, I made a typo, but it was smart enough to understand that. And as you can see now, it can actually remember my name properly. Okay, let's recap what we built. We created a console-based AI agent in Python. We gave it strong persona. We added a weather tool with input validation, and finally turned it from a stateless to a stateful agent so it can remember the conversation. From here, you can swap Diogenes with a more polite assistant or replace the mocked weather with maybe a real API. And you can also connect your own tools for your projects, databases, APIs, whatever you like. If you found this useful, like the video and subscribe, and let me know in the comments about your thoughts. Thank you very much, and see you on the next one.